Section 7.5b is about real-world problems, specifically those that involve systems of inequalities. Here's the problem we're going to look at. Jamail mows grass after school and pays him $3 an hour, and he has another job as a library assistant for $6 an hour. Because of school, his parents allow him to work at most, that's a key phrase here, we'll come back to that, at most 15 hours per week. How many hours can Jamail mow grass and work in the library to still make at least $60? First thing we have to do is come up with two unknowns. We need an x value and a y value. Well, what we're comparing here is we're looking at two different jobs and how many hours he works. So we're going to x be the number of hours that he spends mowing, and y is the number of hours that he spends at the library. Now this is a classic, what I've called a purchase problem. There's this value. What is the value of his hours that he works mowing, and how many hours does he work? So if I take the fact that he makes $3 per hour, we don't know how many hours, so $3 per hour would be 3x. We add that to $6 per hour at the library. Now we know that at least he wants to make at least $60 a week. Well, what does least mean? If it's at least 60, we want to be bigger than or equal to 60. So that's one of our inequalities. The other one, and I'm going to make this a little bit smaller so I can fit the other one in there. The other one is simply this 15 hours per week total. If I add my 2 hours, I have to do at most 15 hours, which means his parents want him to stay under 15 hours, and it can equal that, so that would be my second inequality. So we're going to graph these two inequalities and see where if they overlap. I'll isolate the y. So 6y equals negative 3x plus 60. Divide everything by 6. Negative 1/2 x plus 10. There's my first equation. We'll do the second one since we're right here. So y equals negative x plus 15. Notice my graph is only a first quadrant graph because we're dealing with a real-world problem. So that means we only graph things that are in the positive quadrant, x and y. So let's go down here and find a couple ordered pairs. 0 gives me a 10. How about a 20? If I plug a 20 in, that'll be a negative 10, so 20, 0 will work. That's good. I like to use those, especially in real-world problems. I like to use the intercepts. So let's figure out what my graphing needs to be. My x has to go to 20. So this is how I'll label my x values, and my y's got to go up to 10. So let's make that my y values, and we'll graph the blue line. 0, 10. Whoops. 0, 10, and 20, 0. Because it's greater than or equal to, my boundary line is going to be solid. And there we go. Now we'll do the second one. This will be my red line. Ordered pairs. 0 gives me a 15, and it looks like 15 gives me a 0. So let's graph that. 0, 15. So here's 0, 15, and then 15. This is 12, 14, so 15, 0 is going to be right there. Less than or equal to means this boundary line will also be solid. Now the one thing that I did not do yet is I didn't determine shading for any of them. So let's go back to this original one. I got to try 0, 0. So 3 times 0 plus 6 times 0 is greater than 60. Is 0 greater than 60? No, it's not. So for the blue graph, I'm going to shade away from 0, 0. So I'm going to shade up here in this area. For the red equation, I'm going to try 0, 0 into the x plus y. So 0 plus 0 is less than or equal to 15. Well, that's correct. So since 0, 0 is on the true side, in the red one, I'm going to shade down below. So my solution is this purple area, this area in here where they crisscross over. Now let's see how that applies to the question we were asked. How many hours can Jamail mow the grass and work in the library? Well, he can do anything in here, any combination. So he could mow for 4 hours and work in the library for 9, and that point would be right there. He could do that. He could mow for 2, 4, 6 hours and work in the library for 8. He could mow for 0 and work in the library for 14. Any of these points in here could work for him. And that's a real-world example using a system of inequalities.